So let's just zoom in a bit here. So this one, it might seem like at first it's infinite because when x approaches 0, it diverges, it shoots off to positive infinity. But for infinite, we need it to be infinite from both the left and the right. And there is no left here. There's no limit x tends to 0 from the left for f of x. So it's actually continuous on the domain 0 to infinity. So it's not infinite here. Now I could actually make it quite easily have an infinite discontinuity at 0 if I just put an absolute symbol around the x, and then I've done it. But because there's no way to approach from the left, it's not infinite. So this one is fine. This one here, this looks perfectly fine. This is continuous on minus infinity to infinity. No issues there. This can be written as x over x times x minus 1. So you can see as you approach from the left or the right 1, we shoot off to plus or minus infinity. So it's infinite discontinuity at x equals 1. But you can actually cancel here the x's to remove the problem of not being defined at 0. It's actually removable at x equals 0. This one here, this one is clearly an infinite at t equals 0. And likewise here, this is an infinite when at x equals ln 2, because then we're divided by 0. We've seen this one in a previous question. If you plot this, you get a graph like this, where the graph goes minus 1, and then once you pass 2, it jumps up to 1. So you can literally see the jump at 2. This one is infinite whenever it's infinite when 2x equals n times pi over 2, where n is odd numbers like plus or minus 1, plus or minus 2, plus or minus 3, etc. So if I just divide by 2, I can make that 4 then. Yeah, I think that's okay. Because with tan, just normal tan, these infinite discontinuities, that first one happens at pi over 2, and there's another one at minus pi over 2. At pi, we're okay, because tan of pi is sine pi over cos pi, and that's 0. So the next one here, I think, is 3 pi over 2. So the odd multiples of pi over 2. I think this is okay. This can be written as t plus 3 over t plus 3 times t plus 2. So that's infinite at t equals minus 2, and removable at t equals minus 3. Let's check the answers. Okay. Removable at 0, infinite at 1. Okay. The log 2, infinite at log 2. Then infinite at, you know what? I can't believe this. I said odds out loud, but I actually wrote down all the numbers. Even though I said odds, 3, 5, etc. Does that match up with this? Yeah. K is 0, that's 1. K is 1, that's 3. K is minus 1. That's 1 minus 2, that's minus 1. Yeah, okay. So I said odds, but my brain automatically wrote 1, 2, 3 because, you know, that's what you've learned since like kindergarten. Okay, so that's okay now. That's okay now. Oh, I'm so tired, my head. All right. Can I do a few more before collapsing? Okay, more classifying. Still got sound. We still got sound. Okay. Right, let's clear this off. Right. For the following exercise, the function is continuous at the given point. If it is discontinuous, what type of discontinuity is it? So I think what I'll do is I'll just factorize the top to get a better picture here. 2x, x, 3 and 1. Minus and minus over x minus 1. 2x by x, 2x squared. Minus 1 by minus 3 plus 3. Minus, oh, that's not the right factorization. Does it? Okay, it has to be 3 and 1. But maybe it does not. What factors now that I think about it? Or it's just the other way around. 3 and 2 makes 5. I could go with that. 3 and 2. 2x by x, 2x squared. No. That would have to be 1, wouldn't it? Minus 3 by minus 1 is plus 3. And then minus 2x minus 3x is minus 5x. Okay. So I can see this is definitely a removable at x equals 1. Okay. That's interesting because tan of pi is 0. So this is moving towards 0. Sine of pi, that's 0 as well, isn't it? But cos of pi is minus 1. So this is shooting off to infinity. It's infinite, I think, at theta equal pi. What's happening here? Oh, yeah, at u is a half. Okay, so I think it's worth seeing the top factorized. I'm going to guess it's 2u minus 1 times 3u plus 2 over 2u minus 1. 2u by 3u is 6u squared, minus 1 by plus 2 is minus 2. That's 4u minus 3u is u. So u is a half. This is looking good. 3 times a half plus 2 is 7/2. Yeah. So this is looking like a removable, because you can get rid of this, and what will happen is, as you approach u as a half, this guy will approach 7/2, and the fact that this is 7/2 at that point you can't be at in the previous function, it works out nicely. So actually it's not it's perfectly fine function actually. This is continuous at u equals a half. Yeah, okay. Ooh, I could change that into sine pi y over sine pi y over cos pi y. So sine pi is 0. And yeah, so this is a removable at 1, because you could remove this here. Yeah, it's a removable at y equals 1. Okay, now let's see what's happening here. Okay, interesting. So at 0, as you approach 0 from the right, this is approaching -1. And then as you approach 0 from the left, this is approaching 0 minus e power 0. So it's a quadratic minus an exponential. Quadratic. So I'm not sure exactly the shape, but I think it's going to be something like this, whatever. And it looks fine. It looks like, to me, it's continuous at x equals 0. Yeah. Okay, and then here you have x sine x, and here you have tan x, which is sine x over cos x. So when x is a little bit less than pi, this is trying to approach 0 from the left, and then from the right, oh, this is an interesting one now. That is interesting indeed. That's also going towards 0. That's a funny one now. Why have they got that one there? This looks like it's continuous at x equals pi. Tan pi is fine, isn't it? It's 0. And sine pi is 0. And yeah, what are they trying to do with this one? I'm not sure. Let's check if these are right. What numbers are 139? No, it's a removable discontinuity. Removable at 1. Okay. 141. Yes, it's continuous. Yes, okay. 143. Yes, it's continuous. Real pity I don't have the answer for 144. Might make a graph of it before finishing for today. Um, yeah, yeah, I might make a graph of it. Then I think that'd be a good place to wrap it up. Let's do the graphs for those three. 140, 142, and 144. Okay. Sine x minus cos x over tan x. And we're looking at pi. Yeah, that's infinite there. An infinite jump. Infinite. Maybe I should recall an infinite jump. Okay, and then 142 is sine pi x over tan pi x. Yeah, it's removable at 1. The graph doesn't convey the fact that you've got these undefined points here. Okay. And then this one here, I'm not sure. I can actually do that one in Maxima. Because I learned recently how to do the block. Okay. Fx is defined as block. If x is less than 0, then x sine x. Else then, oh, it's not less than 0, so it's less than pi. Else then x tan x pi. Pi. Is that just pi? Is that how we do it? I forget. What did I? Space else. Let me just see if that's how we get pi. I forget. No, that doesn't seem right. Do I need? I probably need the brackets. How do you? Oh, I remember. It's like percent p or something, isn't it? Ah, forget how to get pi. All right, just cheat for now. That's roughly it. Okay. Fx. And then I want to be around pi, so I'll just go from 3 to 4. Pi equals Oh, hang on, something doesn't look right here. Okay, there we go. Right, so pi is around about here. So, yeah, dips down to 0. Looks more linear on the left than it does on the right, but no. It's just because I have so much more on the right. Yeah, looks, yeah, continuous at pi. That looks good to me. Okay, so I'm pretty happy with these. What's coming up next then? Oh, this is interesting. In the following exercise, find the value of k that makes each function continuous over the given interval. So we have to find the k in each case that will make the function continuous over the given interval, but no interval is given. Yeah, I know what they mean, but I think it could have been clearer here. I think what they're just basically saying is make sure this function is continuous over the reals. This would be over the reals. This would be over the reals. Over the reals. And because the root, I assume they mean here over the positives, including 0. Yeah. Okay. I think that's good. Like I said, I'm very tired. Hopefully I didn't make many mistakes. But if you spot something, please let me know. Thanks for watching. We'll leave it there, and I shall see you next time.